Hi everyone, I'm Liwenhan. Now I will present the paper Wakey-Wakey, Animate Text by Mimicking Characters in the GIF on behalf of the authors from UIST', Fudan University, and MSRA. This work is rooted in the prevailing applications of kinetic typography, meaning animated text as part of the motion graphics design. You may see this vibrant text in films, lyric videos, and advertisements, which effectively deliver subtle emotion or semantics through text animation. With Wakey-Wakey, one may make a video opening like this. Generally, to create a kinetic typography, it is not easy. Creators can turn to complicated animated software and carefully design each keyframe and arrange the timeline. When the design intent is fuzzy and the goal is simply to convey a cheerful mood, it is too demanding to craft a kinetic typography from scratch. And available instances lack adaptability for new combinations of letters, since many animated effects concern deformation. On the contrary, it is relatively easy to find a meme GIF or sticker with motion matching the intended vibe. So intuitively, this work explores a way to animate text in a similar manner of an anchor GIF, so that the intended semantics or emotion can be expressed. Transferring from GIF motion to text animation can be regarded as a motion transfer problem that has been widely studied. However, existing approaches are largely based on a given model, meaning that both the static source and the video target share a similar structure. In the recent 3 years, there emerges computer vision models featuring model-free motion transfer, but they operate in the raster domain and do not generalize well for text. In summary, there are two challenges for the idea to animate text by mimicking a GIF. The first is to construct a mapping between the static text and the target, and the second is to maintain the legibility of the text. So this work proposed this workflow to accelerate the generation process. The input is the target GIF and the static text, and the output result is a kinetic typography mimicking the motion of the target. There are 3 computational modules that addresses the 2 challenges, and creators can get in the creation loop by tweaking algorithmic details or keyframes. Here is the demonstration. With the driving GIF and static text, cross-domain motion transfer is applied to extract motion key points of the source and the target in an unsupervised manner. It animates the text in the raster domain. Then, the colorful motion key points are mapped to the vector control points of the text using affine transformation and optimized locally to maintain the relative position of adjacent control points. In this way, the static text wakes up. This is an authoring interface using the approach. Users can specify the text and the driving GIF, and then manually adjust the motion key points, or directly manipulate the control points on each frame on the result. And this is a demo of a plugin supporting real-time generation in online messaging. To ensure that we are doing the right things, this work conducted intensive evaluation. The evaluation study examines each computational module to validate their contributions to a satisfying result. The case study investigates whether the approach reliably produced legible results. The questionnaire study takes a step further to validate that the essence in the target GIF is indeed preserved in the generated kinetic typography. And the user study investigates the authoring experience of people and their perspectives of the application. Next, I will selectively discuss some interesting findings. For different target GIFs, the automatically generated result is the most stable for a clean background with only one simple object. To scale to more diverse GIFs, we can enlarge the training dataset of the backbone model or integrate with large general models. And for different source static text, the approach works the best for fonts with many control points, because more control points ensures more stable local structure. The text length also matters because it determines whether the text can look like the target. In the user study, after trying out the systems, participants acknowledge its practicality in formal scenarios like presentation or casual scenarios like vlog making. They enjoy customizing their text, seeing the value in personalized expression, and they find the creation process pleasant and efficient, which strikes a balance in agency and automation. There are two major limitations. First, the text deformation might not be stable across frames. Future works may consider propagating the vector control points or leveraging a universal visual model. Second, the animated effect is limited to deformation and motion. But there are more to consider in kinetic typography design as summarized in my recent paper. Future works may consider scenarios like multiple text and graphics, and investigate more creative styles like transferring the visual styles from other domains. Last, let me share the key takeaway messages. This work demonstrates an approach to support high-level authoring intent on semantics or emotion with cross-domain references. Sometimes people care more about crafting one piece instead of going into every details, especially for animation. And this work allows editing with intuitive intermediate results, which reduces the fine-tuning effort. In developing generative AI systems, it is important to give access to the end users and lower the barrier for them in fine-tuning the generated result. So thank you for your attention. If you have more questions, feel free to email me.